We are Team 51, and we performed pump analysis and testing for H2O for Humanity. H2O for Humanity has over 200 water purification systems in India, and soon they'll be moving to Mexico as well. The systems purify water with staged centrifugal pumps and reverse osmosis systems. The team has been tasked with optimizing the efficiency and design of the pump systems, as well as to research the feasibility of CFD software. We are also tasked with designing and constructing a pump testing device so that our models can be tested for accuracy.
The team analyzed the free software OpenFoam, as well as a commercial add-on CFD software called Turbo CFD. The team looked at the pros and cons of each of them. If you look at the Turbo CFD, we were only able to obtain a free trial for it due to the full version costing $10,000. Now, Turbo CFD uses dedicated surface models, whereas OpenFoam is free. It uses solid models and has a much broader user base of learning resources. At this university, we only learn how to do solid modeling, so for that reason, OpenFoam would be a better fit. And as well, unless the sponsor wants to invest $10,000, OpenFoam being free would also be a better fit for this project, for future projects, and for working with this university.
In regards to the design and construction of the pump testing device, the device uses a variable frequency drive to alter the RPMs. As well, it takes 208 volts single-phase power. It can also be run on three-phase power. There are two ball valves to separate the tank from the rest of the apparatus without heavy leaking. There's also a flow meter and pressure gauge so that you can generate your pump curves. As you can see, our pump curve that we have generated is an exact replica of the published pump curves given by Goldswater Technology for our pump, the 10-stage pump. There's a gate valve for throttling, which also helps us to generate our pump curves. As well, we ran it for efficiency information, and we found that it loses efficiency when it passes the nameplate rated RPM.
In conclusion, our pump test apparatus meets the customer needs and will allow them to be able to take it and use it for further projects to further the research on pump impellers, or to be able to integrate it into a solar power system. And the analysis and testing of the CFD has helped us to understand that unless the customer wants to invest $10,000 in the Turbo CFD program, regular OpenFoam will be a far better fit for this project, for further projects, and for working with this university due to the availability of learning resources for OpenFoam and due to the high cost of Turbo CFD.